Right, so I caught the end of Stuart's talk, which was great because I get to talk about testr, which is the big brother of that 250-line C program that's the most productive thing he ever wrote. So testr is a test runner. Clark Borman, I think, first coined this description of it, and it's actually really, really apt. So testr takes a test suite you've got and runs it. But it gives you introspection, it gives you test selection, it gives you a bunch of really, really useful features, and you don't have to rewrite that every time you change language. Because it's built on top of subunit. It's got a language neutral description of what tests went on. I got tired of rewriting the same thing in different languages. So that's what inspired me to get writing on testr. I will apologise, I may end this early and take a lot of questions, or I may go all the way through till tomorrow morning. We'll find out. It's a Python program, it's up on PyPy, it's easy to download, and it's got documentation. Documentation for users, not documentation that I wrote while I was asleep one night. And I already touched on why, but possibly a deeper angle on that is that from a testing perspective, there's not a lot of tooling out there. There's a lot of siloed things like nose tests, things like C testr, Google have a test runner. Everyone has got the same basic problem that they're solving, redone and redone and redone. And things like TAP and subunit give us the potential to take that up a step and start doing really interesting things like talking about how often tests fail, how long they take. Well, that's kind of obvious, but how much I/O contention do you get between two different tests? We have people, QA engineers, that sit down and write ad hoc scripts to gather this data. Why isn't that something I can just apt-get install or pip install and use everywhere? And testr is not finished by a long ways. It's mature, it's very, very useful, but there's a lot of data mining isn't done yet. Subunit is did you guys get told what subunit is in any sort of detail by the previous talk? No? Alright. Subunit is a streaming protocol to report on tests. So it tells you that a test ran, when it ran, what its name was, and did it pass or fail, and diagnostic information about this. So log files, screen dumps, copies of databases that were corrupted can all be bundled into the same stream and handed from your test runner to testr. And I think I have a... Right. This is what subunit stuff looks like. Very simple, human readable, timestamp, a test name, how long, by giving you, subtract 2 times and you get a time difference. Some tags, this tells us that it was run on worker 0, and it errored. So we get a multi-part, it's just HTTP, embedded in the stream. This is what went on. This is the multiple attachments. You can see there's a standard error attachment about halfway down the screen, a logging attachment near the top. Standard out had nothing in it, and the actual traceback of the error that occurred. Anything that's not recognised as subunit just gets passed straight through by the subunit parser. So if you've got print statements, they just come out the far end. It can be a bit annoying if that misfires, but the really nice thing about it is that you can embed subunit output in your normal build tool. So you can run something that generates subunit from the middle of CMake or the middle of make, and it will broadly just work. It won't just work if you're doing parallel within your build environment. You need to do that outside of it. Here's a question.
Is there actually a decent spec for subunit up on the web? Because I kept on looking at
Would an eBNF be sufficient? Sorry, I didn't mean that nastily. Yes, there is an eBNF for it in the source tree, in the top level source tree README. That describes it, and no, I don't think anyone's taken that and said, here's a programmatically generated parser for it based on it. But as far as I know, it's completely in sync with the de facto parser that's in the main Python library.
I just couldn't find a good, easy, a nice, easy to look at, here's the keywords, here's what they mean. But hang on, I just,
We should come back to that questions. I'll dig up the link and we can talk about it, or maybe after the talk. But that's, yeah, that I believe that exists. And when I say it's a kind of simple thing, this is a fully functional configuration file for testr. The test command says this is the test runner, so this is running the Python subunit outputting test runner. Discover dot, just, you know, automatically look in the current directory for tests and all the directories under it. And that's a standard Python test runner facility. It's not specific to testr. The $list.opt and $id.opt variables are populated by testr. And they are used to control what the underlying test runner does. The test ID option is just a one-line template that says this is how you specify that you want to load a specific list of tests. Didn't expect to be doing speech practice today. And the test list option says this is how you query tests that are in the config file. There are a few additional options, and this probably gives you a bit of an idea about what the application might be able to do. You can filter some tests out by tags. You can give it a default for what test to run. You can tell it how much concurrency it should use in running the tests. And you can tell it how to create, use, and get rid of a virtual test environment. I'll come back to those in more detail later. So the API that testr uses to drive test runners is extremely narrow. I wanted it to be very, very easy to go to a new language and to put together a back-end runner that would work with testr. Because testr's ability to query what's going on will let it go and do parallelization for you. So this is an example of it using that narrow API. If you run testr run -- parallel, the first thing testr does is queries exactly what tests would be run. So the list entry point is meant to tell you these are the tests that can execute. Testr will then partition them amongst however many cores you've got to run tests on and start one worker process per core. With the load test that says here's a temporary file that contains one test per line, very, very simple. They go, it runs, you get back a result at the end of it, and you can go and introspect and see what went on. So the key things are you need to be able to list tests, and you need to be able to run either all the tests or a specific set, and you can choose whether you pass that in as, you know, on the command line as a list of names or through a temporary file. Temporary file I find works better because large test suites will exceed your environment length for command lines. And the list format, this is what I was saying before, it's just one per line. I'm sorry the screen isn't as wide as when I drafted this, so these should all just be one test name per line. The dotted thing here is a Python convention. Subunit doesn't care. If you want to put Unicode 2 towers and birds and hearts in your test names, it will work. You might find it a bit hard to find them on the file system later in your own test suite, but testr will cope. And testr itself speaks this protocol, so most of its commands will let you get back a standard list, which you can then manually edit to get different behaviour out, or to extend testr by scripting around it without having to patch it. And it can also output subunit again for most of its commands, so you can see what ran or a previous run and use the normal subunit filters to edit that, to add tags, to discard tests you don't care about, to pipe it to a different machine. You can even stack testr within testr, so you can have one testr that drives some stuff that's on virtual machines that independently use testr to do parallel testing in that environment. It's a nice level of clarity there. And testr failing just is another angle on. This just takes that test we were looking at before. Well, actually a different one, I told a lie there. It had some attachments, these were the attachments, this was the traceback that occurred, and it gets that by looking at its database of the tests that failed rather than rerunning your tests. So one of the things I really like about IDEs is that you can run a whole bunch of tests, you know, Java, whatever, and you get a list of all the tests, and you can click through them, and you can come back to them in half an hour after a tea break, or you can run a couple, and the other ones are still there. But I'm a command line guy. I really don't like sitting in a GUI IDE. So I get that functionality by using testr failing, look at what's there, run just that one. Or even, testr knows which tests failed. So I can just ask it to run just those tests. And when I fix them, keep asking it to run just the failing tests and keep iterating until the list of tests that are failing is empty, and then go and get a coffee while a full run happens. If you look up here, you'll see it doesn't have that first line of the run one I pasted before. It knows what tests there are, so it doesn't query it. So that can be a slow process in some test environments, so it tries to optimize it away whenever it can. You can see down the bottom of the list that it actually ran 4 tests, and there were 4,500 that didn't run compared to the previous run, and it took half a second. So one of the things that I find people get confused about when they start looking at how to use testr is that the concept of a test is actually a fairly specific thing, particularly in the XUnit sort of model of a test. Things like tap conflate make an assertion with a test. So a test is a single, enumerable, isolated piece of code with no dependencies on other things that are called tests. You can run them concurrently, you can run them serially, and you can address them and run just that one and just that one. Anything else is not a test, not in the XUnit sense of it. It's completely valid for a test to make many, many assertions. And most tap scripts would count as a single test from the subunit perspective. However, tap to subunit, which is a filter that subunit has in its tree, actually turns each outputted thing from tap into a separate subunit entry, because generally that's what people have going on in their head when they approach it. But if you are actually integrating directly into subunit, what you'd want to do is to probably put all the tap output as an attachment. That's what happened. The actual thing that failed as another attachment, the traceback attachment, and to call the whole thing the name of the tap file or the name of the executable, or you know, whatever your entry point into it is. And then if you had 15 tap scripts, you would be able to parallelize up to 15 cores at once using that approach. But the thing that really, really, really gets me happy, as I keep coming back to, is data mining. It's all about getting data out. Because when you're working with tests, you do generally a few things you need to do, right? You need to be able to run them. And you need to be able to figure out which ones aren't doing you any good. If it never fails, maybe you don't really need it anymore. If it's slow and it never ever fails, maybe put it on the back burner, run it once a month or before release, but don't run it on every commit. There are different ways to look at the optimization problem. But the biggest thing you don't want is developers sitting there and going, test run's going to finish soon, and yeah. What's really bad though is tests that sometimes pass, sometimes fail, are in critical bits of the code and you don't know why. And there are lots of reasons this can happen. One thing I've seen multiple times is people start out with a long, slow serial test process and they say, this sucks, I'm going to parallelize it. And they do. And then they say, this sucks worse, I'm going back to serial. Because what they found was they had a lot of interdependencies on other tests that they had not documented, they hadn't intended to have, it's not a feature, and they needed to keep things working. So they would then spend weeks or months, not necessarily of staff time, but from the start of the process to the end, figuring out all of the cases and trying parallel again and again until it worked. It took Launchpad, I think it was 3.5 months of doing that, with a team working full time on it, no less, to figure out all of the problems they had before they could move from serial to parallel tests, which they did using testr. And they took a 6-hour runtime of tests down to 20 minutes on a single machine, just making use of all of the cores. So testr has some nascent, it's got some early stage features that I'm really excited about, but there's potential to add a lot more in that. The one it's got at the moment, well, here's a trivial one. What are my slowest tests? It's a commonly requested thing, and this just looks in the database and returns it. And one of the nice things about this, arguably, I mean, there's different ways you might want to approach it. What this currently does is it looks at all of your test history for which test was slower ever. Until you fix it, that test will stick up there, even if you're working a different part of your code base. So that's good from a certain perspective. Other perspective is, I want the last run. I want stats for just that. I'm going to add that in, but, you know, screw this. But this is the one that really helps folk who are converting from parallel to serial environments, or even serial environments that have flaky tests. Often, when a test fails, it fails because of something some other test did, or was doing at the same time. Testr analyze isolation is a bisection tool for your test run. So you saw that tag before, the workers. Testr parallelizes, each separate worker is tagged separately. So if you've got 4 workers, you get worker 0, 1, 2, and 3. If you get some failures, they might be true failures, and that every time you run the test it will fail. So we run all the failures individually. If they still fail, it's not spurious. Fix your damn test. It's simple. It's no confusion. It's just a bad patch that came in. Everything else, one at a time, take all of the tests that ran before that failing test, the one that passed when you ran it on its own, and run that first half plus that one test. If it passes, that's not what caused your spurious failure, assuming it's just a 2-test interaction, in case anyone was thinking through the logic. And you keep repeating until you have just one test that ran before it and it fails, or you find that you can't reproduce the problem. Now, if you can't reproduce the problem, there are 2 obvious big causes. One, you might have a 3 or more test interaction, and it's possible to write the code to go back and repeat that. I haven't done it yet. Patch is accepted. The other possibility is that you have a cross-process interaction, so you need 2 tests running at the same time to reproduce this. And we've got the data to do that. I haven't written the code, but it's fairly straightforward. We know what tests were running by the timestamps from the other test streams. So we should be able to just, you know, spin a few times, repeating that combination, and see if we can trigger it. Of course, then you might get a 2 test in one stream plus concurrent tests from another interaction. At a certain point, I'm going to let people read their own code and figure out their own problems. But I have personally been saved a lot of time with analyze isolation. I have seen the conversion that OpenStack's going through at the moment to parallel save a lot of time in diagnosing these things, finding hidden dependencies between tests by using it. I suspect, I have no data, I'd love data, but I suspect that something like 99.9% of spurious failures are either just timing race conditions on busy machines or 2 test interactions. Well, they might be caused by any one of a whole bunch of other tests, but you only need one of those other tests to trigger the failure. You've got a helper that doesn't reset stuff at the end of a test, that sort of thing. And this is frankly way cool. But there's another thing. When you start parallelizing on one machine, you start realizing there's a lot of machines in the world. So testr has an API that lets it describe multiple test environments. It doesn't care what a test environment is. It's an abstract concept. It's something that you can ask for. You can ask for 5 or 10 or however many you want to. By size, I mean how many concurrent test runners testr is going to execute. So you configure it. You say, I want you to run 30 concurrent runners. It will then say to your helper, give me 30 labels that each one identifies a test environment. It will then say, hey, in this label execute this command. And that is a back-end runner. It's triggered off that run. And if you've implemented this API on top of OpenStack, for example, you might be running up 30 instances in the cloud, small ones with 1 CPU each, just enough resources to run your test suite and branch your code into that. And then it will go and blat out horizontally across that. Or you might cache those instances. You might spin them up in advance and just have the create call from testr, allocate them and put a lock on them so no one else tries to use them at that point. And then the execute is just SSH to the machine and run this thing inside the code there. Or maybe rsync your code in with the current patch. You know, you can see the shape of the thing. It's a very small amount of glue that you need to do. And when it's finished, testr will thoughtfully say, hey, I'm done with these. At which point you can shut them down, put them back in the pool. I use this locally with LXC. So I've got LXC of older versions of Ubuntu that I want to support. I just say, okay, run my tests on this old version by swapping in one of these environments. And I suspect I'm going to be finishing early rather than late, which is fine. Any questions so far? Nope. Yes.
What's the best Python requirements for it?
For testr, 2.6.
2.6.
2.6. But note that with the test environments thing, you don't need testr on that remote machine. It calculates the command that will be run. And if you can SSH into that machine and run that command, there's no Python involved at all. So all you need to be able to do is say that your coordinator, the desktop workstation or the Jenkins machine, depending on whether you're doing it interactively or for CI, has Python 2.6. It's not a hard requirement these days. The other thing, obviously Jenkins integration, you can spit out JUnit XML using the subunit to JUnit XML plugin and get all your pretty graphs and so on. One of the things I like with testr with the data mining is that, again, you're keeping a record of all the tests that ran ever. So your ability to go back and look at past performance is substantial, and I think this is a much better API for doing it than Jenkins. Jenkins, you're dealing with writing a whole bunch of Java to do your analysis. This, you've got a whole bunch of files on disk with a small command line interface to query them any way you want. It is pretty much 10 lines of shell and some awk to do pretty much any query on the dataset.
One of the Jenkins ones, you can just simply do XPath stuff for various XML files, which is a little bit annoying, but it's pretty simple.
Yeah.
I was wondering, could you just throw subunit at this already? So if you had something else that was running it, you just say import this subunit, import this subunit.
To testr?
Yeah.
Yeah, so testr has an underlying command, testr load, pipe whatever it is that generates subunit through testr load,
yep, and
it will create a test run containing the contents of that stream.
Excellent.
If you have the ability to pass additional file descriptors in, you can also give it parallel. That perhaps needs a little bit of glue to hook up properly because no one's tried to do it. But the internals of testr run -- parallel are create multiple threads in Python. It's not doing any complex work, so we don't care about Python's performance from a threading point of view, and attach each thread to testr load with a separate file descriptor for that back end, and it then takes the file descriptor, wraps it up in a subunit parser, multiplexes them into one stream and writes that down to disk.
So I was just thinking that, existingly I get subunits spat out for each job, but if I could just all splat it in and run an analysis on it, it means I don't have to worry about changing anything.
Yep, absolutely. You can do that. The parallel, sorry, yes, questions for what we've done so far. Absolutely.
So you're saying that you want to capture everything. Can you upload that somewhere so that you get more than your own test running, or is there any plans to do that type of thing?
Yeah, absolutely. Future plans. I'll come back to that. There is a Samba repository implementation in the tree already, which can talk to the Samba test farm and pull down that, so you can query that with testr. But the UI doesn't let you glue the two together, so Yelmer has got something arcane and magical in his local tree that lets him use it. But we would both like to make that considerably better.
When you run testr in the parallel mode and a test fails, is there a way of querying what other tests were running at that time?
Well, absolutely. So at the moment it's manual, which is to say you do testr last, which will give you the output of the last run, through -- subunit, which will give you the raw data. You can also just cap the file from disk. It's a very simple disk format. But testr last -- subunit will give you the subunit stream that contains every test in the order it was reported, actually the order of completion, but they're all time-stamped. So what you want to do is you want to build a start-finish map of all your tests from that stream, and then take the tests that failed or the tests that failed and report everything that overlaps that. So that's probably 25, 30 lines of Python. The parser library is in Python, so you can just use that, and you need to write a little handler that says, here's a dict with test metadata, look at that, decide how to stash it in my map table, and then at the end of it all, do the query.
Sure. Okay, thanks.
Yeah.
Have you got any plans to support JUnit or TAP natively? Just for the recording.
Yep. For the recording, the question was, are there any plans to support JUnit or TAP natively? Well, it depends what you mean by native support. So the interface to testr that it has today is that it reads subunit and it reads lists that are one test per line. And it runs an arbitrary command line that you put in its config file. So if you put Perl thing through tap to subunit in the config file, that's what will get run. Testr will see subunit that comes out the end of the tap to subunit filter. I think that's, it's kind of the Unix approach, small tools, let them do their thing well. So I don't see any, if I saw a benefit of doing something other than that, like a way of making testr better or more capable, or we could get better fidelity for tap, I'd certainly be open to the idea, although I suspect I would push it into the underlying libraries that testr depends upon, so that it can be reused for other purposes. There isn't currently a JUnit XML2 subunit filter. It should be very easy to write one, and I'd expect it to be used in the same fashion. Feel free to file a bug about anything that you can't do, such as JUnit to subunit, and I'll look at getting those things done. Is that
a couple of questions. With the testr failing, does that reset if you change the source in the meantime? Or?
No, it resets when it sees the test pass. So you've got a failing test.
Yep.
There are two ways you can tell testr that the test now works. One is when it runs all the tests and the test isn't there anymore.
Right.
If you deleted the test, you don't want to know that it's failing anymore. The other is you can fix the test. When you do a test run that includes the test and it passes,
yep,
it removes it from the list. There's currently no manual way of saying, I want you to believe that that test passed without actually demonstrating it. You could pipe a manual 2-line test colon test name new line success colon test name new line through testr load.
It just seems like a kind of weird bit of state that command line things don't normally have. Well, but I can see how it would be useful also. Yeah,
so the failing, I guess look at it this way. The failing thing is some state that it tracks for you because its job is to track state about tests. If that state's not interesting to you, just ignore it.
Yep.
Don't run -- failing, don't look at testr failing, you treat it as a normal test runner. Could we add a thing to say reset all the failures? Certainly, I think that would be a useful thing to have. And on that thing, you could also put in reset the failure status of a specific test. No one has needed it. I'll be quite happy to add it. There's no philosophical objection to that.
Yeah, just curious. And also, you mentioned that it doesn't play very well with test runners that have their own parallelization.
Right.
So I was just wondering about that because I know that the library we use, PyTest, will order the tests when it's parallelizing them to minimize unnecessary setup and teardown.
Right.
And so I don't know if that seems quite useful, or do you think it's just...
Okay. So there's kind of two angles there. There's a technical limitation that drives this. Subunit is a streaming format that only understands one test running at a time, so that the timestamps apply to the test and you don't think that that other test started at this time. Now, I'm considering doing a rev to the format and making another optional thing that will do interleaving so that you can throw multiple streams into one without doing any sort of buffering. That I think would have some benefits, but it will make the parser more complex and make it harder for people to want to write parsers in another language. That, though, the current status is that if you run two test runners that both output subunit, attach them both to the same file descriptor, you'll get things like test X starts, then test Y starts, and test Y, subunit will go, hang on, that's not valid. the other test hasn't finished, it either has to assume the other test failed and insert an error there saying that test runner died, and then later on it's going to get down and it's going to say, oh, hang on, now I've got it. So that's why. In terms of optimizing setup and teardown to avoid redundant things, you're generally looking at things like setup class and setup module when you're optimizing resources across multiple tests anyway. And the definition of a test in the XUnit sense is that they're independent. So there's kind of a quasi-state where you need this for performance, but from a modeling point of view, you don't want to know that that thing happens at all. I've got another library I wrote called test resources, which is stock PyUnit compatible, so unit test 2, any unit test in current releases of Python, that doesn't tie this to classes or modules. It just takes arbitrary data on the test case, and then it does a sort across all of your tests to optimize that, and it can deal with arbitrary costs, so you can have resources that are very expensive to set up, less expensive, and that sort of thing. But at the testr level, the reason testr might want to care about that is if you have, say you've only got 4 cores, and you've got a resource that's only used 3 times, so it takes 10 minutes to set up, you probably don't want that split across those 3 cores. Currently, there's no answer for that. You would pay that cost of 10 minutes on each core if it happened to schedule them separately. And because it would see them as being 3 very slow tests, it probably would schedule them separately because it's a static scheduler. So once it gets into that state, it'll be very hard to get it out without resetting its timing database. I would like to do something about that. The OpenStack Tempest guys are having a discussion with me at the moment where we're trying to figure out how best to deliver that, because they've got some really high setup costs because they're bringing up full clouds and setting up disk images, and they don't want to stamp on other tests' feet, and so some sort of solution will be forthcoming soon. Fortunately, HP is paying for me to help the OpenStack guys do CI/CD stuff.
You're welcome.
But I don't have an answer for you today. I think the key thing I'm looking for is to find a small lean API that will let us do it well, let people implement the metadata for it in their own test runner easily, and not be a burden or a pain for people that want to do things like testr in other environments. So something that people could adopt happily. All right, I think that's all the questions for now. So, future work. I've still got a few minutes. Yeah. So, as I mentioned before, testr currently has a static scheduler. So, it builds a database of how long every test took to run, and it updates that as tests run. And when you tell it to run in parallel, it just fills the buckets from the most expensive test to the least expensive test. And tests that have never run, it assumes are free, because obviously. And just, whatever bucket's got the most time available, it puts the next test in that bucket. It's not correct, but it's good enough for most people most of the time, particularly when you're first stepping from serial to parallel. It's very hard to actually get things to be worse, no matter how crude your scheduling algorithm is. What I would like to do is to move to an online scheduling system where it asks less tests to run at a time, and has some way of saying to a test runner that's already paid its startup cost, here's some more tests to run. I want to avoid having expensive test runners have to be re-invoked many, many times, and I'm debating and ideas from the floor and from anywhere else are absolutely welcome, how best to do this, what the engineering trade-offs should look like for it. If we can get to the point where we can do online scheduling though, we can then do things like starting up a whole bunch of instances like that narrow test environment API I described before, and as soon as one of them becomes available to do stuff, start scheduling tests onto it, and when the other ones are ready, start giving them tests. And it will let us deal with test environments that have different CPUs, or some might run tests twice as fast as other ones. I've got better hardware, newer hardware. An online scheduler will take care of that naturally. It will just dispatch a small enough fraction that the one that is slow doesn't get asked to run anymore, and the other ones have finished. At the moment, this is all, you have to manually tune it. I don't like that. As I said before, identifying isolation issues is, I think, kind of the thing you spend a lot of time on when you're dealing with parallel testing. I'd like to get the automation, what other tests were running when this one failed, 3, 4, 5-way interactions done. There's some non-polynomial stuff in there. It gets very expensive to look for lots and lots of different permutations. So I'm looking for one of those shortcut algorithms that gives you a reasonably good answer. It might not be perfect, but it's as soon as we can get the probability that you're going to run into something that doesn't work with it low enough, I don't care anymore. Right? This isn't academic research, this is engineering. And I'd like to make it really, really easy to say, hey, show me the tests that fail sporadically, show me the tests that are really slow every now and then. Show me the tests that have most recently been added to the code base. Show me the tests that fail in combination with other code changes. So there's a whole bunch of really interesting data mining questions that I think we've got the data to get at. And question?
So if you're working on different branches, say an older version of a project and leading edge, and you have different tests, I'm just curious how where the data gets stored. Is it under the project name and the global database? So you don't want to overwrite basically your head data with old stuff and vice versa.
Yep. Yep. So the question is, if you're dealing with multiple branches and you've got a single workspace, does test repository keep the data about each branch separate? Can you tell that tip did this and the last stable release did that when you start looking at data mining? And the answer is at the moment no. You could have a symlink that you switch when you switch branches and just point that at a different test repository for each branch. But I think it is something we're going to need to get an answer to when we start doing one of the other things I'm interested in, which is having an HTTP repository. Because if I have a big HTTP repository that I can just take a test run that's happening locally and set a copy of it up for other people so they can see what my experience with running your tests is like, or a build farm could run, whole VMs doing completely different environments without having a single central coordinator. In fact, there's a big difference when you've got the Jenkins thing, I've got 10 different test runs I want to do, from parallelizing one run. 10 different runs, they're going to be running the same tests, different contexts. So you want to be able to tag that stuff, make sure it's clear what it is, and bring it back. So one answer to your thing is, have a single .test repository directory, and set a tag, and change the tag that you set when you run the tests, so that you can tell that test was part of head or part of a previous release branch. That wouldn't immediately get you different timing databases or anything, but it certainly then that will give you the metadata, so you could look at how you spread awareness of that deeper into the system. Right now, the way you would tag is you just add through subunit tag name onto the command line that you run. And you'd probably want to do pipe subunit tag, instead of saying tag name, you'd want to say $ open bracket get branch, that, get back the branch name, and then it'll do it all for you. Yeah, that's where it's at the moment. I've got 10 minutes of questions you guys need to ask me, or we're going to be leaving way early.
Just how's the data stored in a database?
In files. The data is stored. So, I have a computer here.
Text files.
And I have a console that I made nice and large so I could show you guys things without it being a problem. So there are a few files in here. So I'm not just going to list the whole thing. It won't be very useful. But typing in front of other people, not my favourite game. So each test run gets a unique ID. The unique ID is the name of the file on disk. From an external API point of view, I've documented that the test run is opaque. It's not necessarily an int. We could move to a hash-based format later without breaking any scripts built on top if they read the docs. And the files aren't compressed at the moment, so they can get.
They're subunit files?
Yeah, it's just a subunit stream. Right. So I'll show you one in a second. There's a failing file, which is also a subunit stream and contains only the failure details of the last failure that occurred for only the currently failing tests. So another way you can reset what tests failed is just by zeroing out the failing file or editing it and deleting the tests you don't want to know about anymore. Which is not the right UI, I'm just saying. The times DBM...
Everything possible.
Yeah.
Just edit the database by hand.
Absolutely. That's the property of a good database format. The next stream is the next stream, and the format is a version marker, so I can rev this without causing people grief. I have never needed to.
How much trouble would I be in if I put it back into the real database?
I would love it if you can build in good query facilities and so on.
I mean, worst case scenario, then you'd just be able to run straight SQL, so you could be able to demonstrate reports or something.
Yeah, so I've got no objection to databases. In fact, I've been known to do quite a few complex things with databases. I've just never had the need for this thing, and it's like, okay, what do I want from this? I want to be able to run my tests and get reports and figure out what's failing and automate all the things I'm currently doing by hand. So testr grew by me automating everything I did by hand. Writing SQL was never one of the things I did by hand for test tracking. So, and I've never needed a query that was sufficiently slow, even on the data sets I've got on my oldest machines, that I noticed. But yeah, no, absolutely. I don't know if it would be the default format until it had been kind of proven, but...
Damn it, second software project this week.
And it's day one.
You can go to the newbie session.
So if we look at that file, the ID map name, there is the subunit stream. So I'm still answering the question from the middle there. That's the content of one of the files. So you can literally take that and pipe it through anything you want. I don't know, subunit to PyUnit. Let's see that as PyUnit tests. Get some stats on it. So one of the benefits of it being just plain files is that you can run subunit directly on it. So one of the things I would say is that you probably want in a SQL format to be able to ask it for this ring as subunit for an arbitrary. Yeah. Are we out of time now? No, we're not. Oh yeah, yeah.
So right out of the box, what other sort of languages do you support? I mean, if I want to use this on a C program,
Yep. So the
like make check or something?
The check C unit runner supports subunit. Yeah, cool. And there's a module I wrote that uses a standard C++ unit test unit runner API to output subunit, so you can do C++. And there's shell bindings, so you can do shell. There's at least 2 implementations that I know of, although there's only one in my tree. And there's Perl. Samba has an implementation in C, another implementation in C.
We've got the torch one in C, we've got shell bindings.
That's probably the second implementation I'm thinking of for shell bindings, yeah.
Already mine, I think I wrote it.
Okay, 3 implementations of shell binding, going once, going twice. So, yeah, there's...
Really spit out.
Yeah, so the protocol has kind of a graceful fallback. If you do very minimal stuff, it's very, very easy to generate, and you don't get a lot of richness in it. If you need that richness, you add that in, which means a little bit more code, but it's still pretty straightforward stuff. And there's usually libraries that will do the encoding for you, because I didn't invent my own stuff. I just grabbed something else, you know, it's HTTP chunking for attachments, and dropped it on. So, yeah. I have on my disk a half-done emitter for Rust, but I ran into missing stuff in the Rust standard library, which I was kind of sidetracked onto fixing before I could finish it. So, you know, don't do it for a language that hasn't been finished yet, is my advice.
Could you change the subunit protocol to say what tests depend on each other, and therefore when you run that special parallel test thing though?
Okay, so the question is, would it be possible to change subunit so that it declared, you know, test A depends on test B, and then teach testr to honour that, so when testr runs test A, it would include test B in that test run? Yes, and this is, I mentioned before, we had this general problem of trying to handle expensive setup resources, which is kind of one case where that sort of dependency might exist. And that's the sort of thing some people have proposed. I don't think that's a particularly good solution from an engineering perspective, because it means the model stops being a test as an independent thing, and a test is suddenly something that can do massive graph processing across tens of thousands of nodes before you can go and run that one test that you actually wanted to get an answer for. So I think, yes, you could do it. I would be interested in a patch for it, but only for discussion about how we solve the problem properly, if that makes sense.
I was thinking, yeah, I was thinking the same solution to your problem of setup by making it explicit as setup as a separate sort of test. But couldn't you put it in your list format that you expect?
Yeah, so I suspect that the list format is going to go away, and we're going to have something that's richer so that we can describe additional things. What I guess I was getting at is that the idea of a test that you ask to run, depending on another test that you can separately ask to run but sometimes not ask to run, is a problem. 'Cause let me give you an example. Say you've got a common test that 4,000 other tests depend upon, and you've got 20 cores to run tests on. You know, is the dependency you must run these all together, or is it actually, if you want to be optimal, you should run them together, but you can split them if you want to? What you actually want to do when you've got lots of cores is to make sure that every core has plenty of work to do, and then you want to minimize any waste and redundant effort that happens within each core. And the online scheduling thing also ties into that. If you have a new process in the back end each time you say here's a batch of tests to run, then that dependent test needs to be redone each time you do that. So you're going to have a lot of waste because you've got a new process starting and it's losing all its state. So this is why the dependency thing just doesn't quite feel right to me.
But yeah, if that is the real nature of your tests, that they really do have this dependency, then you're better off making sure that your test runner knows about it so it can figure out the best way of doing it, even if it's not great.
So the examples of this I've run into in the world, that's a valid point. I don't think that's the way to do it, but it's a valid point. There are dependencies that are real physical external things. I need to run HTTPD up and I need to generate an SSL certificate before I can run my tests. 2 minutes. All right, I think I can fit this in. And there are dependencies which are logical ones within a single test runner process. I need to create an in-memory SQL database that contains this schema and inject data into it, and it takes 7 seconds, and I don't want to pay that more often than I need to. I think the solutions for these two things, if there can be one solution, that's great, but I think they're actually really quite different problems. Because I need to run HTTPD and create an SSL certificate is something you can easily cache cross-process. I can have a farm of HTTPDs, and each test runner can just ask for one from the farm, update any data in its config, rehub it, and then go, and that's like a half second. That's, you know, I don't care about that overhead. Not by the time you've SSH'd halfway across the world. That's you know, to get to the server farm, that's where your real overhead's going to come in. But I'm doing something in process. That one I really care a lot about, from the sense of it's very hard to make that into a cache that's available if you start a new process each time you run tests. Once you get those things addressed, then I think you can talk about, if you've got two tests that are independent but are going to benefit from the same shared setup, how do you get them onto the same core and under what circumstances? But from a modelling point of view, I don't think a dependency is actually what you're expressing. I think it's an optimization. And the question about what your tests really look like, I think they can be split into external things that can be in principle cached. You know, that's the port that's just looking on, these are the credentials that that thing has. And there's things that are internal, and testr doesn't need to know about, except as a scheduling hint, hey, all of these things happen to share the same underlying thing. You should put them on the same core. There's a hard one and a soft one, and neither of them really look like a dependency, is this short story. And if I haven't convinced you, I'd really like to get anyone who's interested in this, gentleman up in the back, Rusty, etc., and you know, do a BOF on it maybe or something. I think this is a big thing to get a good answer to.
Yeah, we've got I know that because we've been tackling this in we've been dealing with this. It's a big good thing to buff. Oh, wow, that doesn't really sound like it's doing anything. We've been dealing with this in OpenStack as well because we've got these ever-growing test suites, and there's the impulse. We've had the impulse from some of our lovely developers from day one to over hyper optimize before they had a problem. So we're unfurling some of those things. But then there are the real ones. There's the I've got all these things need a database setup, and running through 75 SQL Alchemy migrations when you start up the process sucks. And so like all of these things are real things, but and then other people, because there's the other optimization, which is there's this chunk of stuff that gets me to where I want to do, and I've got multiple permutations of things, and I want all of those different permutations of drivers to test the same basic functionality in the thing, and I don't want to copy paste that code. And so I've also seen our developers try and express that in a thing that feels more like a dependency rather than because they're trying to save coding time.
Yeah.
You know, and I think all of those things actually can be modeled into the cleaner model. And as we've been cleaning up and getting them to parallel, we've been re-expressing them in the cleaner model. And it's been, we haven't seen a negative downside to doing that other than the work. So.
Yeah, but so what you're talking about them on is that you've been running within the current capabilities of testr, and I'm saying there's another step we need to get to. You had a follow-on on this, didn't you?
Just in terms of dependencies, there's also another one in Tempest, for example, where we don't want to run test A when test B is running, because there could be a conflict with resources.
Well, I think, so if I come back to the online scheduling thing of saying, you know, this is how much work you can have going on at once, one extension to the simple one of this is how many cores you can have running would be to be able to say, you know, and each core is going to use this much resources from some other thing when this test runs. And again, it's a matter of finding a simple, so not conflated with other things, description of what's going on that can be meaningfully interpreted with a cross-process barrier. I'm running these tests, testr is only observing what's going on at a time remove, because it may be arbitrarily buffered by TCP and other latency occurring. If the test runner at the thing that is doing the tests is actually working on a single large shared resource, coordinating that through the test runner is likely going to be poor at best. There are lots of failure modes.
So you think that needs to be handled at a much lower level?
Well, I think that the don't exceed the resources of the cloud you're working on is something that is amenable to static scheduling, because you can describe in advance what every test needs, what resources it's got, and just make sure that you schedule it in advance, but you might need an online delivery of what to run at what time to let that work well. But again, you're going to run into timing problems. You're starting a new process, or at minimum you're telling, send this onto a pipe and hope it gets delivered in a sensible time. And if you've done much multi-processing work, you'll know that when latencies come in like that, it's very easy to have long delays occur because someone forgets to read in a socket at the right time or whatever else. And I'm very wary of a structure that is going to promote that sort of bug. Because testr, I can get testr correct, but I can't guarantee that all of the other things that glue into it, that work with its extension points, are going to get it right. And something as simple as standard out buffering, which is the default in nearly every language, would be a horrible thing to have break people's test performance. So that's where I'm coming from. I think this is too involved this is the wrong forum for drilling into it further, I think.
Okay, thanks very much.
My pleasure.